Hello and welcome, everybody. I'd like to acknowledge the custodians of this land, the Gadigal people of the Eora Nation, and their elders past and present. We acknowledge and respect their continuing culture and the contribution they make to the life of this city and this region. Thanks, everybody, for joining today. This is the 27th Sydney NLP meetup and our second fully online event, so still a bit experimental. Happy for feedback. My name is Ben Hachey. I'm head of applied AI at Harrison and one of your hosts today. Stephen Hogg is your other host today. He's head of systems AI at Harrison, and he'll be facilitating the live Q&A after Johannes's talk. But let's get to the main event. I'm really very excited to introduce Johannes Hoffart today to talk about NLP in the financial domain. Johannes is a research scientist in the Goldman Sachs Core AI group, where he works on natural language understanding and knowledge bases. He's joining us today from Germany, the wonder of Zoom, and it's fantastic to be able to do this, so really appreciate it, Johannes. If we go back a bit, Johannes did his PhD at the Max Planck Institute for Informatics in Germany, in Saarbrücken, which of course is one of the world's top NLP destinations. I'm personally really very thrilled to hear from Johannes today, since I read his seminal entity linking paper from 2011 many times, and I think we have a few people in the attendees today who would say the same thing. Shout out Will Radford. I'm also pleased to be able to share that Johannes's Google search result profile is not completely accurate. This is for two reasons. So first of all, because reports of his death are greatly exaggerated.
I'm an NLP researcher.
And secondly, because it shows that we still have some work left to do. But back to today's talk. It's great to have this opportunity to hear Johannes's perspective on a domain that's full of documents and where NLP really has so much potential. It's also really cool to see the path that Johannes has taken from entity linking to interactive machine learning, which of course is one of our core themes here at Sydney NLP. So last time we had Rob Monroe, who talked about human in the loop machine learning. And Johannes's talk today is a great example of what I like to think of as machine in the loop tools to amplify human intelligence. So the presentation today is pre-recorded and will last for about 45 minutes. Johannes is, of course, live on the Zoom and will be answering questions in the Zoom chat. After the video, we'll have a bit of time for a few video questions. And now, without further ado, we'll kick off the video with Johannes about NLP in the financial domain.
This presentation on natural language processing in the financial domain. My name is Johannes Hoffart. I'm a research scientist at Goldman Sachs, and today I'm going to present to you some extra dimensions for natural language processing in the area of finance. Before I start, just a brief introduction. I did my PhD at the Max Planck Institute for Informatics in Germany in Saarbrücken 5 years ago, focusing on entity disambiguation, entity discovery, and knowledge-based construction. During my PhD, I was working on the Yago project, a knowledge-based construction from Wikipedia, and AIDA, an open source system for doing entity linking. After that, some colleagues and myself co-founded a startup, and we were commercializing this research technology, entity linking, natural language understanding in general. After that, in January 2019, I joined Goldman Sachs as a research scientist. Before I dive into the presentation, just another brief disclaimer to mention that this talk is, of course, built on joint work with many colleagues at Goldman Sachs. However, I remain responsible for the views and opinions expressed here. And they are not necessarily shared by my colleagues or my employer and are for informational purposes only. Also, for those of you looking for confidential information, no luck here. All examples are taken from public documents or are really made up. I guess most of you have heard of Goldman Sachs. Maybe some of you don't really know exactly what we're doing. At least that was the case for me when joining 2 years ago. Let me try to give like a brief outline. I think GS is really a service provider for any business needing financial support in any way, financial advice. So you have a startup and you want to do an IPO, you can go to GS. You want to issue new bonds to get new capital, you can go to Goldman Sachs. You have money to invest and want advice where to invest it in, you can come to Goldman Sachs, and all like in the business domain. For that, more than 38,000 employees are working there worldwide, and interestingly more than 10,000 engineers. So there's a huge engineering operation part of GS. The headquarters are in New York. That's the photo you're seeing on the right-hand side here. The main offices are in London, Bangalore, Hong Kong, Tokyo, and of course New York. There are offices in all other continents, and since 1990 also in Frankfurt, where I am based. 2 years ago, so not very long ago, the R&D engineering group was founded with the goal of doing applied research for Goldman Sachs internally and for really driving a research agenda for the financial domain in different research areas. Also for collaborating with the academic community and the NLP community, in our case, at large. The R&D engineering department is headed by Jeremy Glick, and more than 50 people are working there. The chief scientist is Paul Bashar. The focus areas are digital assets, anything blockchain related, quantum computing, and Core AI, where I'm working headed by Vijay Saraswat. And Core AI is not broad AI, but focused on anything that has to do with extracting information from document using natural language processing, machine learning, and constructing knowledge bases or knowledge graphs. Let me give you a broad overview of NLP in finance. What is it all about? Well, I can't really tell you what it's all about because our group is still exploring the potential for NLP in finance. So what I can give you is a snapshot. Where is it useful? One immediate field where NLP can be useful is valuation, where we're trying to create methods that automatically derive valuation signals from financial statements, analyst reports, or news. Another field is risk. How can we pre-identify events that could pose a risk to individual participants or the market as a whole? Operations, the folks who are actually making sure that everything that needs to be done gets done, we can support them in accomplishing repetitive information extraction tasks more quickly. And for sales, can identify opportunities and automatically tailor offers to clients' needs. So this is really just a snapshot. There are many, many more applications, but I'm still discovering more, but already these are providing a lot of opportunity for new research and development. And one grand challenge that kind of paints a unifying picture across all these 4 pillars is our research on credit agreements, which I will present in way more detail later. The business value of understanding credit agreements is huge. We are exploring multiple ways of extracting value from credit agreements. So for valuation, if you combine the credit agreement terms with financial data, you can prepare accurate data for the valuation process. So you know exactly the current state of the company and the constraints imposed on the company by the credit agreement. And this allows you a really well automated valuation of what the credit agreement, the actual contract, is worth and how you can trade it, for example. From the risk perspective, these are 200, 300-page documents, right? There's always potential for loopholes, and we're trying to identify these loopholes automatically. From the operations perspective, someone needs to take care of ensuring that the contract is actually upheld. And for that, you need to check that the covenants that are imposed by the contract are really adhered to. we are trying to automate these covenant checks. And for sales, there is a huge potential in automatically tailoring these credit agreements to various business needs without a lot of manual intervention. So you see that like the single document type of credit agreement has potential to impact many, many fields that are providing significant value to Goldman Sachs. Finance really runs on documents, right? Credit agreements are just one of the many. So there are contracts, loan documents, reports, financial statements, filings, prospectus documents. Of course, there's news and analyst reports and much, much more. And here it is really just a snapshot to show you also the variety of documents that we have to deal with, right? It's not really just text. There's so much structure in that and so much visual cues. And that's really one of the key differentiators and kind of the source of the extra dimensions for NLP. Caveat up front, most of it is PDF, so you better have a robust PDF parser to deal with all of this. This variety of documents really poses quite a number of different problems that really depend on the nature of the input text. On the very left-hand side, I would say you have the low variance text like forms, invoices, template contracts that are having a predefined structure where you actually do not really need NLP. You actually need vision to say like at this place in the document there's this little field where I want to extract my value from, where somebody else has written the value in. Then there's the regular NLP that we are dealing with in academic NLP all the time, which is news reports, so lots and lots of text where you don't have a lot of structure. You like have a headline and then you have paragraphs, maybe a subsection. And then on the far end, and that's where we are working now, is really where you get the extra dimensions of text. So this is what I want to focus on. I want to introduce these extra dimensions of text. What does this really mean? Across all these problems, you have a common problem, which is that you don't have training data and very expensive annotators. So you better have methods that can either bootstrap very quickly or are few shot, zero shot style. Okay, let's go deeper. So not about NLP in finance in general, but NLP in finance on legal texts, and an introduction to the extra dimensions. This is a prime example of a legal document. It's an ISA master agreement between two parties, the Bank of America and the LKQ Corporation. And you see immediately that to know that it is between the Bank of America and the LKQ Corporation, you don't really parse the text, right? You need to visually comprehend the document. And that's really the first extra dimension, its visual structure. The second extra dimension, the content is really deeply hierarchically organized. So here you see 1A, right? 2A. It can go down to 7.2b paragraph 20 or something, right? So really deeply nested structure in documents. Also what you can see here, a lot of these documents actually have capitalized words, and these capitalized words are defined terms. These, together with the section references, actually mean that this document is not really just text. It's actually densely packed with hyperlinks for humans, right? So you can always follow these references and you can look them up and you can read the definitions. So another extra dimension. And the fourth extra dimension is something that you don't see here directly, but you can spot it if you look closely. It's dated as of March 22, 2011. So these agreements change all the time and they are changing in place. So let me give you, for each of those, a real example. We've just seen the visual structure. The text will be arranged to facilitate the human understanding, right? Not for machines, it's not real text. You need to see, okay, there are two fields, two blanks, and there are companies put there. And this also means, of course, that these documents are formatted to preserve layout. You can't just extract the text and concatenate it in the hope that you get correct extractions. It's also, of course, full of boxes and full of tables. The deeply hierarchical content, here is a better example. You see that the term with the label N, which is kind of a regular outline style N, right? It's somewhere in the document, has an X and an A and a B and a Y inside it. And this means it's actually 2 levels deeply nested in this single paragraph. And the hyperlinks for humans, if you look at all the capitalized words like liens, loan document, liens, swing line lender, LC issuer, cash collateralized, defaulting lender, letters of credit, swing line loans, section 2.03A2E, etc. So in this single paragraph, like half of the words are actually references to some other place in the document. So really densely nested. And the last one, temporal text here, this is actually also, again, taken from a real credit agreement. They're just strike-throughs and replacements of these terms, and you actually have to be aware of what this means to really process the text properly. So, across all of this is kind of something new, that everything is English language, right? You see in this deeply hierarchical content what this actually means, what this investments that do not exceed the sum of the greater of 100 million and be 3% of total assets. This is actually a mathematical constraint that the investments that the company was borrowing from the bank is doing must not exceed more than $100 million or 3% of total assets, right? And that's not everything. There are logical expressions, there are statistical observations, there are strong conditionalities, there are almost something like SQL statements in this text, because lawyers don't like formulas, lawyers don't like anything that looks like a logical expression, so they are actually translating everything to text, and our task is to translate it back to logical expressions and constraints. So these extra dimensions are manifold, and I think are not really well addressed in the current academic research. I'm not sure how folks here in this meetup are familiar with these dimensions. I guess for folks who are working in NLP industry, they are way more familiar with these dimensions than the regular academic researcher. However, there is, I would say, like a trend towards really acknowledging that these issues exist and that they really need to be looked at. So, for example, at this year's KDD, there is a language model that actually takes into account the 2D offsets on the document, or this year's ACL, information extraction from long documents, in this case scientific papers, where also you're not extracting like just simple triples, but long-range dependent facts. So there is work. We're really hoping that we can contribute more research work there, because one of our core missions at the Core AI group is also doing foundational research, publishing research, and of course collaborating with the academic community more broadly to really also drive the research agenda, because these are all really, really hard problems. We don't have solutions. We're definitely not enough researchers at GS to address all of them on our own. So yeah, I mean, we need support from the community. Yet one more layer to peel off the NLP onion. Legal text, specifically credit agreements. Remember, I initially introduced credit agreements as one of the key subjects of our experiments, of our research, because they're used so broadly throughout the company and can provide value in so many different places. They're also really hard to deal with and are a good representation of all the aspects that you need to deal with when doing NLP in the financial domain. Concretely here, the extra dimension that we're making use of most is this deeply nested structure. And this deeply nested structure that is explicitly marked is actually a great guide for knowledge extraction. So let me show you what we're doing here. So just to give you a quick glance of how such a credit agreement looks like. So this is kind of the directory page where all the counterparts, the participants are listed. Of course, this is also something you want to extract, right? You want to get the participants, the counterparties of the credit agreement and their roles within the credit agreement. There's a table of contents, which you might also want to extract. If you go further in the key content parts of the credit agreement, one of them is the negative covenants. So this is basically stating what the borrower must not do. If they violate any of the negative covenants, that violates the credit agreement, which means it needs to be renegotiated, which means that there can be fines, which means that the contract might actually be annihilated. So this is really, really critical. And understanding all of these negative covenants, and you can see that there are many, there are like 10, 20 pages of these negative covenants, is really crucial. Just to give you an idea how important this is, so usually these negative covenants are upheld, right? No big deal. This is a contract, it's usually upheld, it's done in a way, written in a way that it's makes sense for both parties, right? But if a borrower gets into financial distress, then also for the lender, Goldman Sachs or any other bank, it becomes critical to quickly understand the covenants and see exactly what is violated for a variety of reasons, maybe just for renegotiation, just for understanding what the boundaries should be. And just reading this and extracting all the formulas, as the constrained formulas as mathematical formulas, for example, in an Excel sheet, it can take a couple of hours, right? And if you want to react quickly, this is really an impediment. So we want to make sure that this is faster. But this is not everything we want. Professionals want to know from credit agreements, right? Professionals read these documents in depth and understand many, many different parts of the documents and extract knowledge. And we really want to support these professionals in answering their knowledge needs. So for example, when they're authoring or negotiating new credit agreements, they want to quickly compare the new draft to existing similar ones. So for example, they're drafting a new credit agreement for a big automotive company. Well, there are many automotive companies, and the likelihood that there is already another automotive company borrowing from us is quite high. So it would be great to just have this as a quick source of reference. But they're not all in the same region, it's different. So if you are an automotive company in the US, it's different than from the European Union. So again, also here, you want to make sure that you're regionally comparing, right? So just having this metadata around really helps them. Loophole identification is extremely important when authoring and negotiating these credit agreements. So there have been cases where you basically had circular references in the credit agreements that made certain parts of this agreement invalid. And then, well, you cannot enforce it anymore. So really, really important. There's a lot of money at stake. You can also, when comparing credit agreements to existing ones, you can identify outliers and say and quickly see like where, for example, a new borrower is really interested in something specific. And this is important for negotiation because these are the points that you can use as leverage, right? From the risk perspective, they want to understand, given the current financial situation of a company, which of the covenants are close to being violated, or which of them are violated, just to be able to quickly adapt the risk assessment. And again, similar to the negotiators, if you can compare a credit agreement's definitions to the usual definitions in other agreements, you can quickly identify special cases and you need to pay special attention to these cases. And last but definitely not least, professionals want to know the value of these contracts. They want to trade the contracts, they want to maybe renegotiate the contracts because the value has, the perception of value has changed. And this is really crucial. This valuation process is something that is very, very time demanding, and automation is extremely important there. So you see that this requires deep understanding of all the clauses, but especially the covenants are a key differentiator that we are looking at. Let's take a step back and see what these credit agreements actually are. Because even now, folks are actually using Adobe PDF or something to go through these credit agreements, and they're searching in these credit agreements. So even by just understanding the PDF and understanding the defined terms and section references as hyperlinks by extracting the table of contents, you can provide a huge benefit. And this is not just for humans, this, of course, you also want to have programmatic access to this underlying structure of the document. So that's actually one thing that is crucial and that we're working on to get this structure and to get this kind of easy to navigate credit agreement. So, I mean, on the right-hand side, you actually see the same thing as on the left-hand side. The left-hand side is a PDF, the right-hand side is a website. Format and everything is kept. However, you can navigate it as a regular website. So you click a hyperlink to a defined term, you actually get to the defined term and the section references. Similar with the table of contents. This is actually something that you need anyway to resolve the section references, so why not also make it immediately available to quickly jump through the credit agreement. Again, useful both for readers immediately, but also necessary for programmatic access to these long documents. And the last kind of, I would say, visual aid for human consumption, but also for programmatic access is the stanza graph. So on the left-hand side, you see a pretty long single sentence that is kind of marked up by the lawyers with XYZ, 1, 2, etc. And this is actually like a regular nested, indented tree structure, right? So if you display it as this indented list, this is immediately helpful for folks reading it, but again, of course, crucial for parsing this also from a natural language processing point of view. I mean, you will know that parsing is quite difficult, right? To get the association, the hierarchical structure of a sentence correct is key to extracting complex facts. So the fact that we have these explicit markers in the text is definitely something we want to make use of, and we are making use of. These formulas are not only like brief and kind of cute small formulas, right? So the right-hand side is actually an attempt at really writing the formula that is described on the left-hand side as a more or less mathematical formula, right? Still with a lot of placeholders for actual financial data to be, right? So the right-hand side is actually an attempt at really writing the formula that is described on the left-hand side as a more or less mathematical formula, right? Still with a lot of placeholders for actual financial data to be plugged in, but you can get a sense of how complex this can become. And yeah, just to again make this point, right, that constraints, formulas, aggregations, etc. are written in English, pseudo-English, and the sentences are deeply nested with explicit markers. Again, so this is the extra dimension that we're making use of here, and the extra dimension in this case really being explicitly highlighted. And this is not just an outlier, right? This is pretty common that these extra like kind of syntactic markers are placed there, because even for a human otherwise it's just incomprehensible. Once you have the extraction part tackled, you actually want to have explicit modeling. And this is to really, as I mentioned before, combine the constraints in the credit agreement with the actual financial data. So the EBITDA that is mentioned in the credit agreement of a company as of Q2 2020, this we have in some database, but it's of course not explicitly mentioned in the document. The document is really a variable that we want to fill, and then once you can fill all these variables that we've seen in the previous slide, right, you can actually have fully executable formulas. Once you normalize all the components like the entities, the concepts, and relations, you can link it to existing financial data, and you can really compute the actual value, and you can check if the constraint is violated or not. And I mean, this is really a huge step forward, and you can imagine this is really, really tough. So we're not seeing this as like a challenge to be solved in a single paper or something, right? This is like a 5-year grand challenge to get this stuff done. And let's have a look at one of these complex clauses in detail, and how the extra dimension of nesting markers and this deeply nested structure actually guide extraction methods. So this clause that we're going to have a deeper look at in the coming slides is reading indebtedness of the borrower and or any restricted subsidiary in an aggregate outstanding principal amount at any time outstanding not to exceed the greater of X 100 million, Y 11.5% of consolidated total assets determined at the time of incurrence, and Z the lesser of 45% of consolidated adjusted EBITDA for the most recent fourth fiscal quarter period and $200 million. We want to make these terms machine readable. What does this mean? We want to actually have a structure that is understandable by a machine in the sense of each element is uniquely identified. So each of the elements of this graph here is a unique ID in a knowledge base, and the structure is in a way that it can be automatically executed. So compare this to the original clause. You see both are quite complex, but I mean the machine readable clause is of course not only interesting for machine consumption, but also for human consumption, right? You can immediately see the formula and the elements from the machine readable term. What we also want is not just a formula, but a typing of the term itself. So you see in the clause it says indebtedness of the borrower and or any restricted subsidiary. And because the way this is formulated, that this is not an aggregate amount not to exceed, this actually means that this is about the incremental debt. So this is something that we've figured out by sitting down with the business domain experts and really discussing this and how they want to model this. So this is not something that is naturally there, but like just one additional interesting side note, basically, that terminology is, the vocabulary is not very large, but the variety of how terms are expressed is actually pretty significant. The second thing that we want to have is a classification, basically. So into which of the kind of generic classes of terms, constraints, covenants does this actually fall? In this case, it's really debt. There are like 5 or 6 of these classes that we identified. So how do we get there? The first step is to recognize the individual elements in the text that make up the structure of the constraint in the end. So this would be the relation not to exceed, the operators, the greater of and the lesser of, the governors, consolidated total assets and adjusted EBITDA, or consolidated adjusted EBITDA depending on the context, the objects, $100 million, 11.5%, etc. Whenever we see an object, we actually also know that there is a governor if the object is a percentage, as in this case, right? So that also means that the recognition itself can actually benefit from kind of joint inference, right? Just bear in mind for later. Currently, how we're doing this is in this scenario is really with dictionary spotting, right? So we constructed the vocabulary up front. We know all the governors, all the operators and relations, and of course, I mean, the objects we can describe with a regular expression. So identifying the elements is quite straightforward. For temporal expressions, it's not as straightforward. But yeah, I mean, also there you can train like something like a sequence tiger. Once you have recognized all the individual objects, all the individual elements, you realize that they are actually not just objects or elements, they're actually categorized, right? So we have all these different expressions that we can then look up in different places, and that's why it's also easier to spot them, because in contrast to, like, I would say concept spotting in the wild, like in the web or in Wikipedia, here especially the number of relations and operators, because they're in mathematical of mathematical nature, is actually very limited. So it's not such a huge problem to identify relations and operators, and also the governors. There is a limited subset, and this helps driving the initial extraction for these classes. Now, once we have the individual elements extracted, we need to establish their relations, so the interdependencies. Are they on the same level? Are they nested? What belongs to what, right? So is it, for example, in the last sentence, like the and, that is not explicitly marked, but still it's a coordinative conjunction, right? So we have this on the same level, and it's not like like it's a child relation and not a sibling relation. So this is what we want to establish, and here is really where lawyers are helping us along quite a bit by having these explicit markers on the text that guide a lot of the tricky cases. However, not all of the cases are explicitly marked. So again, seeing the example, the lesser of 45%, so that the last, the whatever is in the node Z, there are actually two elements in the node Z, right? The lesser of 45% of consolidated adjusted EBITDA and 200 million. So this is something that we then need to automatically understand. We don't have markups. So what we're doing here, we're making use of the fact that there are constraints. We know that objects belong to an operator and that operators need to link to a relation. So the only thing we need to understand is, like, is it nested or is it on the same level, right? Is it, yeah. And for that, again, a classifier that just does a binary decision on each of these questions. So now we have this structure detected. We want to normalize it by linking to a knowledge base. Again, this is done by lookup in the taxonomy. Now you realize that the type in the provision, what was formerly in the top left, is missing. How are we getting there? Right? After we normalize everything in the remainder of the constraint, we actually want to also normalize these parts. And again, for bootstrapping, we developed taxonomy of provisions and types. The types can be shared among multiple provisions, so it's not like a partitioning of the provisions. So we can't directly infer the type from the provision. We need an extra step. You also see that there is some kind of nesting going on. So junior secured is a like sub-provision of secured debt, but it's not a huge taxonomy. For bootstrapping, we assign each of these elements in the taxonomy kind of string representations, how they can occur in the text. And based on that, we're generating the training data to really do the provision and type normalization. So given all the other elements, what is the provision and what is the type? Given the provision, we have the current context of the provision as additional feature, as additional context. And for the type, we actually make use of the fact, again, that the document is deeply nested, right? We have the title stack. We know that this particular clause, indebtedness of the borrower, etc., is part of the credit agreement, covenant, negative covenant section, and limitation on incurrence of indebtedness, etc. section. And we feed all of this into a classifier, and the training data is actually bootstrapped by the initial vocabulary dictionary lookup with some refinements by humans in the loop. And now, voila, we have our machine-readable term in the credit agreement. As I mentioned, I just want to drive the point home. We are in an environment where data generation is extremely expensive because the annotators actually have day jobs and they need to do this on the side, basically. So one of the kind of key insights that we're following is we're trying to build something to bootstrap quite quickly, like with zero-shot unsupervised methods or with rule-based methods for initial annotations, let the users use the system and correct it, and then use this training data for more sophisticated methods for fine-tuning and for really creating like very accurate and high recall methods. So, as I mentioned before, this machine-readable clauses is not only interesting for machines, but also for humans. So basically, what we can do is we can show all the terms as we are extracting them in a nice tabular view, something that an analyst would actually do manually from these credit agreements, and really saving a lot of time. So this might be a tad small, but on the right-hand side, you see the actual document. The context is masked because this is a confidential document. But the output is really the provision, the type, where it occurs in, and then all the concrete bounds, objects, governors in there. So it's really, really easy to read, way easier than reading the full context. Now, just looking at these terms is nice, but of course, having all these machine-readable terms, we can also do much more. We can do a semantic search over credit agreements. Things that our business professionals want to know are things like, show me all terms with a capital is over 50 million, or show me every tech company with a leverage maintenance covenant, or given the set of companies, of these 50 companies that are interesting for me, do they contain a cap on cost savings and debts, and what is that? Using the extractions that I just showed you, we can actually answer these questions. Let me show you the first one and how we're actually doing that. In the tool, the semantic search is really an ontology-driven search, right? So you're basically exploring the space of terms in the documents by navigating through the ontology. So you specify the type, in this case indebtedness, the provision, capital lease and purchase money debt, the bound, which needs to be at least 50 million, and the bound unit, which is US dollars. And you see here that we're actually normalizing the values, right? So we really understand that 50 million is not just a string, but it's actually a number, so we're also parsing this, and we can show the results across all documents. And this is really powerful for doing analysis, and this is not something that you can do in any way by human effort, right? Because you cannot actually read all these documents in any sensible amount of time. It's simply not possible. So this is really powerful. So to conclude, I want to give you a quick overview of the toolkit that we're using to achieve all this, right? So what are the technologies, what are the methods that we're using? First step, is exploring the document collections that our business professionals are working with notebooks often, and really doing pipeline-based NLP, right? So parse speech tagging, NER, to quickly filter, to quickly get an insight. Heuristic filtering of terms and phrases based on POS patterns that define domain-specific terms, or really simple string transformations like deleting certain terms, and then simple counting. What are the most frequent terms and phrases to get something as basis for discussion with the business professionals. And this is all the basis for really bootstrapping the applications and training data. Out of this initial analysis, we generate shallow class hierarchies that anchors extractions for extraction rules, right? As I've shown in the credit agreements. If you know all the relations, if you know all the operators, you can actually do an initial extraction of these elements, and then simple feature-driven classifiers for resolving structural ambiguity, right? Again, as in the credit agreements, this is really like a very basic semantic parsing, but in this case it works quite well because the labels that the lawyers give in the text as kind of visual markers actually are a very good feature for that, right? And then, based on that, developing continuously learning applications. For these, you want to use really, really strong, powerful methods like pre-trained language model embeddings for similarity retrieval, and of course classifiers based on pre-trained language model classifiers. Always trying to use semi-supervised, distantly supervised active learning. So anything that drives down annotation costs. And for that, both of them using approximate nearest neighbor libraries and BERT mostly. Approximate nearest neighbors we're actually using because you've seen that the documents are really long. And if you just execute classifiers on every single page and every single paragraph, not only does it take a very long time, it's also very costly to annotate the data, right? So that's why the nearest neighbor lookups is like you're having kind of weak supervision. You're annotating some samples and then you're retrieving similar ones and annotating more. So everything here is to be taken with a grain of salt. This is always just rough guidelines, right? In practice, we're doing things slightly differently, but this is just to give you a gist of how we're usually doing things. Once we extract the knowledge, we want to explicitly model the knowledge using representations that actually can represent deeply nested and complex knowledge, settling on a combination of like GraphQL, JSON-LD, Shackle, and kind of the semantic web stack with recent extensions. And yeah, for efficient and configurable lookup, for full text search, standard Elasticsearch, and for yeah, the semantic web stack, of course, RDF stores. So this is giving you like a glimpse into what we're using to get kind of from text to knowledge. So it's basically one tour de force through the history of NLP, from simple heuristics to very complex human-in-the-loop architectures. So to sum up, natural language understanding in finance needs to deal with a variety of problems. First of all, it's kind of deals with an industry that really runs on all kinds of documents, where the documents really have legally binding power. So you better make sure that you get things correct, especially when the language verbalizes maths and logics and statistics, right? And you need extremely high recall. So all of that together, with scarce data and expensive annotators, you can imagine that this is like a really tough nut to crack. However, you get interesting additional dimensions that you can make use of, right? So you're getting this visual structure that is geared towards kind of human 2D recognition, right? You're actually looking at the document not as like a linear chain of words, but as a really 2D object. We've made a lot of use of the hierarchical structure with the deep nesting in the credit agreement project that I've shown you. There is dense document intra and interlinkage, meaning you have a lot of external kind of context that you can make use of. And sometimes also temporal nature of documents gives you additional hints of what is important or not. I didn't really detail this too much just now. I want to close with kind of open research questions, which are mostly driven by these extra dimensions, right? So there is very little research on language models with visual structure. Like all of these, not just like 2D, but like what is a section, what is a table, etc. Textually linked documents, right? How can you make language models actually deal with the fact that this is a linked document? It's not really just text sequentially. And the whole field of information extraction from highly structured language to their fully logical and semantic form, I mean, yeah, there's tons of open questions, right? So I hope this kind of triggers some exciting ideas in your minds. And again, thanks a lot for taking the time to attend, and I'm happy to answer any further questions. Thank you.
Okay, thank you very much, Johannes. That's a very interesting presentation, actually, and we've had some good questions already while it was going on. I'd like to start off with one of my own, if that's actually all right. Where Ben and I work at the moment, one thing that exercises us a fair bit is, I guess, how to do something generically. So can you shed some light on that in the context of the problems you've been talking about today? So for instance, if you wanted to take some infrastructure that you'd built for analyzing credit contracts and move it onto something else, what sort of challenges and tasks do you foresee would be involved in that? And like, do you try to take account of it when you're building stuff?
Yeah, definitely. I mean, this is a very relevant question. So the group is kind of pretty young, I would say. It's like 2 years, right? And a lot of the time initially we spent on identifying the interesting use cases that are really, where you basically assume that you can bring some value without spending 5 years upfront, right? And we have been working on many of the use cases kind of, I would say, in parallel, without much looking at like what is the potential for reuse, because like once you start going for reuse, you can I mean, it takes a lot of time, so then you can provide value to the immediate task so quickly, right? So we have explored a lot, and I think right now we are at a stage where we kind of understand the reusability better, and are really trying to go for this kind of platformy approach, where you say like, what are the reusable components, where are the reusable ideas. And I think one of the things that already came up in the chat, right? So this the parsing of the structure of the formulas. That's something that definitely can be generalized, right? And that is a problem that comes up. I can also start the video again. That's a problem that it doesn't only come up in credit agreements, right? It comes up in analyst reports. It comes up in any kinds of structured financial products. They all full of formulas, right? So like if I have like a product that is a derivative of some underlying stock options or stock equity, whatever you want to do it. I mean, there's this huge universe of financial products that is basically deriving from other underlying products, and these are all formulas. So definitely we want to generalize there, and I think the way we're trying to go about it is to identify these individual building blocks, where the formula extraction is one, and then trying, like this already came up in the chat, trying, for example, semantic parsing methods, right, that are in some way addressing these problems, but not fully, right, and try to adapt them to these problems. Or one of the frequently recurring use cases that I didn't mention here is just doing like more or less straightforward information extraction from long documents, right? So where you say like, what is the in this filing, if in this quarterly report, what is the consolidated adjusted EBITDA? And in every report, it's somewhere else, and every report looks different. But the underlying idea that the context is similar can be reused in the form that you basically do a two-stage approach, saying like, first we're trying to identify the place in the document where this is most likely occurring, and then extracting it from there. So very similar to how you're doing span-based question answering at this point in time, right? So kind of trying to find like for which problems we can use which method, and then making it reusable, and making a kind of a, I'm trying also to get closer to something that is usable by business users directly. And currently, but currently we're not really there yet. I think that this is also somewhat of a chicken egg problem. I think we have, by now we have more headway by things like BERT and GPT-3, where we just have more powerful methods where you need less training data or even no training data and just basically have few-shot learning. But it's still kind of something that you kind of need to iterate through. So yeah, I hope that kind of gives a bit of an idea. But it's not really a solved problem, right? So I also can only give like some initial thoughts there.
It does. That's really interesting. Thank you. Emily Sue, go ahead.
Oh, hi. Thanks so much for the presentation. It was super fascinating to learn a bit more about NLP. I'm sort of like a beginner to NLP. I haven't really explored it all too much, but it was super fascinating. Thanks for that, Johan. I just had a question for Johan. You mentioned about you're working on the project to sort of find out how to actually sort of pass PDFs, because as you mentioned, like EBITDA and all those different financial terms, they're different in every report. And I've sort of done this process myself, trying to automate the inputting of financial data from financial reports into a specific format I want. But then I've realized that every report does it a bit differently. And I think you mentioned something about you're working on this problem. Can you provide a little bit more sort of insight about how you would approach trying to systemize something that's kind of different in each report?
Yeah. So that like one of the initial slides that I had is like basically going from if you have like something that's super templated, it's kind of a vision problem, right? But we are in this kind of weird spot where it's a mixture of like vision and NLP. So I guess what the very first step that you need to do is really trying to map the PDF, or that's what we're doing, is trying to map the PDF to a representation that actually allows you to navigate the document programmatically, right? So you know what a table is, you know what an outline list is, you know what a section is, and then you can start identifying the common places where you usually find the EBITDA values, right? And really seeing this as a bootstrapping a machine learning problem where it gives some seed sets of like, these are the paragraphs or these are the table cells where it usually occurs. And then you can use these initial seeds to find more similar documents kind of in a weak supervision, weakly supervised setting where you're using the semantic similarity between paragraphs or tables or whatever. And in this case, semantic similarity really being embeddings of any recent language model, right? That is usually quite precise and allows you to quickly get new spots in other documents where this value is usually located. And then you have like specific information extraction methods, but they are usually not so tough because these you have the anchors, right? You know it's a number, and you know that somewhere in the vicinity of the number you will find the term EBITDA, and then it's like a matter of understanding if it's like to the left, to the right, or whatever, right? But that's kind of a simpler task. So for like these straightforward things like unique value asks, I think that is an, kind of a process that might work. Thinking ahead, I think like using something like GPT-3 based question answering, maybe you can get rid of the initial lookup step, right? Or maybe if like language models become more and more powerful, maybe you don't need to retrieve the passage anymore, but you just really run through the full document and do the extraction on each passage, and it would still somehow work. So that's kind of also to be explored.
Great, thanks so much for the answer.
Sure.
Okay, more questions from the crowd. Anyone interested? All right, my turn. One question that kind of niggled at me a little bit while you were talking was, as I guess a few people have said, a lot of these contracts are really bespoke. How useful is it to get something like an over-the-counter derivatives or swaps contract just as a pre-training sample and use that?
So I do think that you can get an improvement by pre-training BERT further on internal like or financial data, right? Financial documents. Mm-hmm. We have done that. We have explored it, and you do get some improvement, but it's a question of like so it doesn't really come with usually the complexities of the agreements that we do have. So I would see this like as a two-step thing, right? So you can pre-train your language models and then it will work better, but you can't really look at the structural issues so well because the lengths of the documents are different and the level of detail is different. So the methods might not work in a similar way. However, I guess it's what we want to be doing, which we haven't really gotten around to doing yet, is look at exactly these kind of over-the-counter things or over-the-counter documents that, so for example, some of the master agreements are actually publicly available, right? And need to be filed with the SEC. So you can actually look at them and try to create data sets on that, at least approximate the problems that we're working on for the and doing research on, right? So definitely it is something that we're looking at, but it's also, yeah, not fully explored yet. We unfortunately, I would like to present kind of like, this is a data set, right? Please go ahead and work on it, but yeah, we don't have that yet.
That sounds like a dilemma.
Yeah, I mean, this is, I think the SEC filings are quite rich, so I guess we will be able to do something from that. So for example, one initial idea that we had to create a data set is kind of mapping the questions that you would get through an earnings call back to the filings, to the quarterly reports that the company did, and just see like how many of these questions could you actually answer by reading the quarterly report, right? Unfortunately now, of course, like the quarterly reports are public, the transcripts of the earning calls are not, right? So there are always these things where like, oh no, finally I found something nice where we can really do an exciting data set, and then it's like, okay, but this data is proprietary, so how do we work around that, right? So there, we haven't really found the sweet spot for having something exciting that is easily accessible, unfortunately. Yeah.
Okay, well, keep trying, I guess.
Yes.
Next, I saw Jochen Leidner. You put your hand up. Have you got a question you'd like to ask? If so, just put your hand up again and I'll give you permission to talk. Yep. Go ahead.
Thank you, and thanks, Johannes, for a fantastic talk, and good to see you again. I hope everybody on the call is well and happy. My question is about the problem as it relates to other problems that you're dealing with at Goldman Sachs. So you've picked one to present here today, which is extremely interesting and related to a couple of things that I've been working on, and some of my colleagues as well. Some in a different domain, even in legal. But I wonder, you know, this is a hard one. So are you also working on sort of lower hanging fruits, or are you more dedicated to the sort of complex side of things? So I guess it's a question about, you know, the repertoire or set of problems that you address as a group, or the, you know, are you dedicated to this highly specialized problem, which I'm sure, you know, can give a dozen of people a lot to work for a decade?
Yeah. So we are really dedicated to looking for problems that are high risk and like need to have a long-term investment, right? Because like usual business teams can't really take like projects on that have like a multi-year horizon. So that's why these problems are kind of the most important ones for us to look at. And also like spawning new research questions and then trying to solve them for the foreseeable future. With the goal in mind that, of course, this will also generate business value at some point in time, right? So it's not like blue sky research, but it's also not trying to pick the low-hanging fruit only. There are by now actually quite a number of vendors that try to address low-hanging fruit. So, for example, the problem that I presented with like the templated extraction, right, where you have like highly regular visual documents, that's something that vendors can take care of by now. And also there are other teams, I would say, that are looking more into like low-hanging fruit, but of course it also depends on how you define it, right? I mean, for example, I wouldn't define single value extraction from a quarterly earnings report as low-hanging fruit that is done by others, right? So that's something that we see for in our realm, because it's tough, right? It's not something that you can do off the shelf. But of course, it's by far not as complex as extracting mathematical formulas from credit agreements and kind of making them executable, right? So we do have like a bandwidth or a breadth of problems that we are attacking, but we also try not to. I mean, if there is a vendor that can solve our problems, that's the best thing that we can encounter, right? So yeah. But for example, even for PDF extraction, right? So we're talking to many folks. Nobody does PDF extraction at the level of granularity that we would like to have, right? So it's like you can get like, this is a table, this is a page, this is a section heading, but like analyzing the structure, for example, in the paragraphs itself, or analyzing really complex tables, there's still like some work to be done.
Thank you. Thanks very much.
Sure.
Okay, have we got any more
I've got
questions?
my hands.
Ben Hachey.
Thanks for the talk, Johannes. Really, really great. I really like how you frame the bootstrapping applications approach. And I think the task sort of lends itself to that kind of approach as well. But I also think it's a challenging thing to do. So I'm really curious just to hear a little bit more. Sort of, maybe you could say a bit about how you identify the key features that provide enough value to users to be able to get them to start using a system. And also, I mean, I guess there's a UI side to it. So I think you showed us the sort of the browser interface, and maybe that's part of the answer to the UI side of it. But how do you think about the UI side of it? Is the other part of the question, and then of course, how do you collect the feedback and close the loop to bring that back into a sort of closed loop machine learning or continuously improving system in whatever way?
Yeah. So yeah, that's like very, very important questions. No final answers on that yet, but I can try to highlight what we're trying to do. So one thing that for bootstrapping, you can usually get the business folks involved to contribute to the bootstrapping approach because they are like, I think that's one great thing about working at GS, really, that folks are really keen on driving innovation forward. So we have many teams which are really interacting a lot with us and contributing a lot to like help us understand the problems deeply, and then also contributing something like these shallow taxonomies that I was presenting, or where we're saying, okay, like, this is the value that you're extracting. Show us 10 documents where you're extracting these values, and we're taking it from there, right? So this does work quite well because folks are really heavily involved. Closing the loop on the other side, I think that's more like a problem that we haven't fully figured out yet. So the UI that I've shown, you can basically edit all the terms in place. So you can say, okay, this is the wrong provision, this is the wrong type, and you can actually have a drop down that uses the taxonomy in the background to give the users the kind of suggestions of what should be the case, what is the true term there. And this is stored back in the same format as we are producing for the web UI, and this is also the same format that the machine learning models are trained on, right? So in principle, we can close the loop there. What we haven't figured out fully yet is like how to do this like autonomously, right? So to decide when to retrain and to decide like, is the signal to noise ratio good enough, right? So all these things are not automated. So we're really still like looking at, oh, there's feedback, let's look at it. Can we just push a button, or do we need to go deeper, right? So there's still a lot of like experts from both sides, from the business teams and from our teams involved. But I do think that it's feasible on our domain, maybe even a bit simpler than in the general space, to use the feedback, because folks are usually very precise when they give feedback, right? So it would, I guess, rarely happen that they give the wrong feedback, right? And another project that I'm working, which is like completely different, which is about personalizing public knowledge, so personalizing your newsfeed or something. Again, we are doing the same kind of approach, saying, okay, like, you can give us feedback, so this news is not important to you, just tell us, right? There, it might be more noisy, and there it's unclear to me, like, if we can really do this very simply. So this is a very initial thing, right? So we don't have this fully worked out, but yeah, it's a completely recurring problem that
yeah.
I guess maybe one more thing that makes this easier is because the latest pre-trained language models make so much more, give you so much more value out of single training items. So when fine-tuning, you get like a lot of value out of single feedback items, which I think simplifies the problem a bit. So 5 years ago, I think this would have been like pretty much impossible to get as much training data as we would like to have.
Yeah, great, thank you.
Yeah. Ned Letcher. Go ahead.
G'day. Yeah. Right. Okay. So one of the things I've done work in this area, and it feels to me like, as you said, basically PDFs are sort of the worst possible document you could design for this. It's like text is encoded in an X and Y coordinate, and that's just kind of pretty crazy. So my question is, ideally it'd be better if this was, we had an interchange format where you'd actually encode the kind of information we're looking for. Do you envision a world where we solve the coordination problem and, have some sort of format that we all subscribe to?
I mean, I think you can always be an idealist, right? And hope that this is going to happen. But somehow I feel that this is so deeply entrenched by now that you have to deal with it at this point in time, right? In parallel, of course, we're pushing for more standardization across all these areas, right? Not like, how do you represent a document that is a PDF, right? How do you represent this programmatically so that the extraction methods can deal with it? That would actually kind of naturally lead to a format that you can also kind of just start writing your contracts in, right? If you have a semantic model of the contract and all the important parts, you could like create modeling tools that would allow the lawyers to write in this. But the workflows are pretty ingrained. So you have these like Word documents with like tracking mechanisms turned on, and then they are sent around in X iterations, and folks are quite used to that. So you would need to, I think you would need a huge initial effort to get to a point where it really is more like less time consuming for the lawyers to write in the specific platform that you build. And also you need to solve the exchange problem, right? So what if two lawyers are writing in different platforms, right? So now everybody kind of agrees in Word and PDF because that's kind of the established stuff, but how do you get the platform to be accepted? So I think it's, there's a huge effort needed. So that's why basically we're saying, okay, we need to deal with the reality right now. So let's just deal with PDF. And at least PDF, you have the visual markers intact, right? So you know that if somebody put a line somewhere in the PDF, it means something, which is also a good thing, right? So it's not all bad with PDF.
Maybe one day we'll finally get to my promised land of absolutely everything is a massive JSON blob. One last go around for anyone else who wants to ask a question. Andreas Wöhler, how deal with different taxonomies, similarities and differences?
That is a broad question. I'm interpreting it in the way that it makes it the easiest for me to answer, I would say. So currently the taxonomies that we are using for the like really domain specific projects are constructed per project, right? So that we don't have like a lot of exchange going on for them. However, in another kind of, so we're basically having two directions to follow. Like one is this credit agreement style, internal document style knowledge extraction, where the taxonomies are pretty much focused on a single document type or a single use case. But we're also looking at information extraction from documents where connecting the knowledge to public sources actually does make sense, right? So where you want to have Wikidata in the back end and where you want to do the linking to that. So for example, to just understand which counterparties are involved in the contracts and getting more background information for them. In this case, we try, of course, to align the taxonomies to our internal ones and derive additional value from that. Not sure if that answered the question, but that's kind of what comes to mind when I read it.
In that case, I guess I'd like to take this opportunity to thank you for a very interesting talk and some very interesting question and answers. Thank you for joining the show, as it were. Hopefully we'll see you again around here soon.